Let's read the question. A curve is described only by its gradient function, and we know one point it passes through, P. We're given the gradient function and the point P on the curve. And we must find the equation of the curve, then the point Q where the normal at P meets the curve a second time. So here's what we're working with: the gradient function and the point P, aiming for the curve's equation and then the point Q. Here's the key idea for Part A. Differentiating a curve gives its gradient. We're handed the gradient and want the curve, so we go the other way and integrate. Going backwards always leaves an unknown constant, C, which the point P will pin down. Now Part B pictured. This is the curve with P sitting on it. The tangent just grazes the curve at P. The normal is the line through P that's perpendicular to that tangent. Follow the normal along and it cuts the curve a second time, at Q. Finding that second crossing is the whole of Part B. Step 1. To get the curve back from its gradient, we integrate. So y is the integral of the gradient function. We integrate by the power rule. Add 1 to the power, then divide by the new power. Term by term, 4x gives 2x squared and 6 gives 6x. That's the curve, written with an unknown constant c. The common slip is dropping that plus c. We need it, and we find its value next. Step 2. The curve passes through P, so put x equal to 1 and y equal to 4. Here's the curve with the unknown c. Substituting the point in. 2 minus 6 is minus 4, so 4 equals minus 4 plus c. Adding 4 to both sides, c is 8. So the equation of the curve is 2x squared minus 6x plus 8. Step 3. The gradient function gives the slope of the tangent. At P, x is 1. Putting x equal to 1 into the gradient function gives a tangent gradient of minus 2. The normal is perpendicular to the tangent. For perpendicular lines, the gradients multiply to give minus 1. So the normal's gradient is minus 1 over the tangents. Flip it and change the sign. Minus 1 over minus 2 is 1/2. That's the gradient of the normal. Step 4. Build the equation of the normal, a line through P with gradient 1/2. We use the straight line form through a known point. With the point P and gradient 1/2, we get this. Expanding and tidying, the normal is 1/2 x plus 7 over 2. Step 5. At a crossing point, the normal and the curve share the same y, so we set them equal. The normal's y equals the curve's y. Clear the fractions by multiplying everything by 2. Bring everything to one side to get a standard quadratic in x. This factorizes neatly. One root is x equals 1, but that's just P itself, so we reject it. The second crossing is at x equals 9 over 4. Step 6. Put x equals 9 over 4 back into the normal to get the y coordinate. Substituting x into the normal. Over a common denominator of 8, That adds to 37 over 8. So Q is at 9 over 4, 37 over 8. Final answers. For part A, the equation of the curve is 2x squared minus 6x plus 8. For part B, the normal meets the curve again at Q, 9 over 4, 37 over 8.